getting recorded this thing, you should attend the classes. So you guys are attending, but many times, I mean, some people are not attending, I'm seeing. So so they may lose out because of various reasons. So one thing is that we may have a surprise, short quiz some days. Okay. Okay, so let me start. Yeah. So any questions? Just to recall, in the last few classes, or in the last week rather, we have discussed about the constructors, copy constructors, etc. Okay. Then we have discussed about the const keyword, so various notions of constness in the context of member functions and member variables. Okay, and also different constant objects. Okay, and then we have talked about discussed this notion of static member variables and also member functions. Okay. Yeah, so those are actually so we have discussed that they don't have the this pointer, right? So those are related to the class rather than the instance of a class. Okay, so today we are going to discuss another sort of another functionality, you can say, which is added by C++, which is using this particular keyword called friend. Okay. Okay. So so what is the what is the friend function? Okay. So towards the left, you can see this program where, I have this my class, which has a private data member, which is int data underscore. Okay. Now, and I have this display function, which is taking an instance of, so this is a global function, not a member function. Okay. And this is taking an instance A of my class, actually a constant reference to that. Okay. And then it is sort of trying to print that. Okay. Now this will result in an error. Okay. And the reason is that display is a global function. Okay. And the data is a private member of the of my class. Okay. So what so basically inside display you cannot access the data field like this. So a.data is not accessible. Okay. So this is the problem. Okay. So what friend does is, or rather, in this particular case, a friend function does is it allows you. So this concept is also also called encapsulation, as you all know, right? Okay. So what friend keyword does is it allows you to selectively break this encapsulation. Okay, so what do I mean by that? So basically in the same program, you can now look at the program to the right here. Okay, in the same program, what you can do, you can declare this global function display, okay, as a friend function of my class. So this is how you declare the global function as a friend function of my class. You say friend, and then you provide the full prototype of that function. Okay, so this is just declaring that this particular function is a friend function of this class. Okay, this is not declaring, this is not defining a new function or anything like that. Okay, so in that case, you are allowed. Okay, so you are allowed to access this a.data. Okay, so this display is a non-member function, but a friend to this class, my class. Okay, because it is friend, it is declared as friend inside my class. It is able to access the private member, which is data, and hence it is able to print. Okay, so this is one way in which the a friend function can you can use a friend function to selectively break the encapsulation. Okay, so okay. Yeah, so a friend function of a class has access to private and protected members of the class. So we will see in a moment what are protected members. Okay, in a few classes, a few classes. Yeah. So, but essentially, you can for the time being, you can just think of protected members as also private members. Okay. Um, okay. So now. Yeah, so it must have a prototype included within the scope of the class prefixed with the keyword friend. So this we have discussed. Okay. Uh, does not have its name qualified with the class scope. Okay, so this is another thing, that even though this display function is a friend function here, it's not a member function. Okay, or it's not even a function, it's not even like a static function whose name is qualified with the name of the class. Okay, so the so even that is not true. Okay. Okay, is not called with an invoking object of the class. Okay, so obviously, yeah, so you cannot declare, so you cannot say something like, my class obj10, and then you cannot say obj.display. Okay, so it's not, it doesn't work that way. Okay. Um, uh, can be declared. Okay, so yeah, so other thing is any function can be declared as a friend function of one or more classes. Okay, actually zero or more classes. So it can be, so you can declare the you can define the function as a global function. Okay, and then you can make it friend to many different classes also. That is also allowed. Okay. Okay, now what kind of functions can you have as a friend function? Okay, so obviously we have seen the global function, so any global function can be a friend function. Okay, moreover, a member function of another class can also be a friend function to a particular class. Okay, so this is another important feature which we will look at. Okay, and of course, a function template can also be a friend. Okay, so we will see, we have not seen templates, so we will see templates in a minute. Okay, in a few classes. Okay, so okay, so now let us look at one application of this friend function. Okay, and basically here what we are doing is um, uh, we want to do this matrix vector product. Okay. Um, okay. So okay. So we first, so there are two classes now. Okay. So earlier there was only one class. Now there are two classes. Okay. So our basically our objective here is to declare a function like this prod function, which can take in a matrix and a vector and return a vector. Okay, something like this. Okay. Now, now how will we proceed? Okay, so I will come to why you need this kind of a of forward declaration. Okay. So first, let us see, we are defining this class vector. So vector is basically, it's a vector of size 3, and then maybe you can also store the dimension. Okay, and then it is the constructor of the vector. You are doing an initialization, some sort of an initialization. Okay, And you can do clear, you can do show. Okay, so so these are all useful. Now here we are saying that there is this function prod, which is a friend of this class vector. Okay. Okay, so this is one thing. Okay, and this function prod, remember, takes a matrix as an argument. Okay, so hence you have to at this point the compiler does not know about this type matrix, so you have to do a forward declaration. Okay, so this is just a declaration of the class. This is not a definition of the class matrix. Okay, so it is just saying that there exists some sort of a class. There exists some type called matrix. Okay, and yeah, okay, so this is how it is. Okay, now here after this we are defining this class matrix again. We are defining it 3x3 matrix here, but it can have any size which is less than 3. So m is the number of rows and n is the number of columns. Okay, and here we are defining the constructor. We are doing some sort of initialization. Okay, and also we are sort of taking in m and n. Okay, and we are also defining the show function. Okay, now here also we are defining this friend function vector, a product. Okay, which takes basically a matrix and a vector. Now already vector is defined, so it knows what is a vector. So it just you can just define a friend function here. Okay. Okay, now we do the actual definition. So these are all the function vector being declared as a function. Okay, now we come to the actual definition of this function product. Sorry, not function vector, but function product. Okay. Um, okay, so here what we do, we declare it as any normal function. Okay, and basically what this function does is it takes a pointer to a matrix and a pointer to a vector. Okay, and then it creates a new object which is of type vector, and its dimension is basically the number of rows of this matrix M, because it is computing basically M times V. Okay, and then it is clearing it. Okay, and then it is calculating this matrix vector product, which is that it is calculating every entry I here. Okay. Okay, now why do we need to have this as a friend? Okay, this is because you see both the data int and n, okay, are these private in class vector and class matrix, and this is how it should be. Okay, now you can do two things. You can either have get set kind of functions and use those here, or what you can do, you can declare this prod as a friend of both these classes, and in this case you can access, you can see that you are accessing this pm arrow m and then pm arrow n. Okay, and then pv arrow e. Okay, all of this you are able to do. Okay, and you are able to do this because of because it is a friend. Okay. Okay, so so just to discuss here, you see, you could have also had a alternate design where you could have had this prod also as a member function of one of the classes. Okay. Anyway, so that is a different point, but just wanted to make this point clear. Okay. Okay, now yeah, so you can just say use it like this, that vector PV is equal to prod of address of M and address of V. Okay, and then it will do basically the product of these two matrices. So you are initializing the two matrices and then you are doing the product. Okay. Okay. Another interesting example here. So here, okay, so let us look at the second example. Okay, so now we are again trying to create a linked list class. Okay, now there are, as you all know, you need two classes, right? Two types. One is the node, the other is the list. Okay, and we are doing again a forward declaration of node because you need node here. Okay, and then you are sort of storing a pointer to the head and a pointer to the tail here. Okay, and you have the usual constructor. Okay, where you are basically yes, where you are supplying the head. Okay, and yeah, when you are constructing, your head and tail are the same. Okay, and now you have a display function and you have a append function. Okay, here for the list. Okay, now in the node again you have the info and you have the next pointer here. Okay, and now what we are doing is again this display and append function should be able to access this info and next. Okay, and we'll see how. Okay, so what are we doing here? We are saying that this member function of the list class, which is the display, which will be written in this particular scope as list : display. Okay, that is a friend of the node class, and similarly the list : append is a friend of the node class. Okay, so you are here now you are defining a member function of one class as a friend of the other. Okay, okay, and yeah, so display is just it does browsing and then prints the info. Okay, and your append basically does an append to the tail. Okay, so this is the usual linked list implementation that you are doing, and then yeah, so this is just you can create a list, you can create a few nodes. Okay, and then you can append all these nodes to this list and then you can do the display. Okay. Okay, so yeah, so here the key idea is that the class list is built on the node class. Okay, so it is kind of so you can one way to think about it is that the node class is kind of a utility class for the list class. Okay, so in this case, so actually what the user will access mostly is the list class. Okay, so okay.
Sir,
Yes.
sir, I am not able to understand this definition of this list constructor. Like node star h equals to 0. So this is giving h null, or it is telling that the value stored at the address of h is 0.
Okay. So it is giving h the default parameter for h as null.
So means okay, h is null, not the value at h is 0.
Yes. So h. So this is you see this is the default parameter. Okay. So
Yes,
h
sir.
is null. Yes, h is null.
Okay, sir. Got it. Thank you, sir.
Sir,
Yes.
sir, I have a doubt in this type of declaration. Like 0 is treated as integer constant. Then what sort of type conversion takes place here?
What sort of type conversion, right? So it is the integer to pointer conversion, right?
Okay, so 0 is interpreted as null and type conversion also takes place.
Yeah, so null is declared as 0. It's actually yeah. So yeah. Okay, so
Okay,
this
so
0
then,
is, yeah, 0 is taken as the unsigned integer 0. And it's converted to a pointer. So this is probably not the best way to do it. We should probably just do here null. Okay, so yeah. Okay, okay. So so that was about the friend function. Okay. Okay. Now you see here, one thing is that so almost all member functions of this particular list class, okay, are friends to this particular node class. Okay, so they are very tightly coupled. Okay, so in order to, so there is a better way to, so instead of declaring each and every, so this is very selective, right? So every function has to be individually declared as a friend function. Okay, what you can do, you can also declare a class as a friend of another class. Okay, so if a class is declared as a friend of another class, okay, then basically any member function of this class, okay, has access to the private and protected members of the friend class. Okay, so the friend class of a class, okay, has so it's the other way around. Yeah, so the friend class of a class has access to the private and protected members of that particular class, where this class has been declared as friend class. Okay, does not have its name qualified within the class group, so it's not a nested class. Okay, uh, and again can be declared as a friend of more than one classes. Okay, and again friend class can be a class or a class template. Okay, so we'll see discuss this when we discuss templates. But so now this is the same example but with the friend class. Okay, so same example, you see we have done a forward declaration of node, then we are doing the list class. Okay, now while in the node class I'm just declaring the list as a friend class of this node class. So I just do this particular statement where I say friend class list. Okay, so what does this mean? This means that now all basically all private members of the node class are accessible to all member functions of the list class. Okay, so then the same code basically follows. Okay, so so this is how so list class is now a friend of the node class. Okay, and since list class is a friend of the node class, so now it has full visibility into the internals of node class. Okay. Okay. Um, um,
Sir, does this go both ways?
no, it does not go both ways. Okay, it does not go both ways. Okay, so so you have to then declare the node class also as a friend class of list class. Okay. Okay, so okay. Now we are just we are on the subject of linked list. So so we can declare what is called an iterator class, okay, or an iterator object. So so this kind of objects are very widely used in like STL and I mean almost all languages. They provide some sort of iterator support. Okay, so now here we are sort of declaring this iterator over a linked list. Okay, okay, so what does this iterator class have? So iterator class will have the list, of course. So it will iterate over a list. Okay. And it also has to have a node because, you know, it has to store the current state of iteration over the list. So just to understand what the iterator class does, basically it provides you functionalities to iterate over the list. Okay. So this is what it is. Okay. Okay. So this is the iterator constructor. Okay. And typically it will have this kind of 4 functions. So one is begin, which will basically initialize the iterator with a list. Okay. Then there will be a end function which will check whether you have reached the end of the list while iterating. Okay. Then there will be a next function which will basically increment the, you know, the move the basically iterated to the next object in the list. Okay. And then there will be a data function which will basically access the, you know, the data stored in the list. Okay. So so you can see here in the main how iterator can be used. So if you define a list L and some nodes, okay, then you can define an iterator I here, okay, and then you can you know, run a for loop something like this, which is that I dot begin ampersand n. Okay, so here you are initializing the iterator with the list L, and then while not I dot end, okay, uh, I dot next, okay, and then you can see out I dot data. Okay, so this is basically how you use iterators, you know, yeah, so this is how you use the iterator. Okay, so now, so you have the list class, which has basically 2 nodes, as we discussed. Okay, and it has head and tail. Okay, and of course the node class has info and next. Okay. Now this this function of, so the append function remains with the list. Okay. So yeah. So and what you do, okay, so and you now declare the, so you have this iterator class. Okay. So now what you do, you declare this iterator as a friend of both list and node. Okay, and of course you have to declare list as friend of node because you have to use this append function. Okay, so then you see you are you can implement all the functions. So you can implement iterated the begin, okay, with list. So you basically set node to L arrow head. Okay, so you basically set the current node. Okay, then you are just checking here whether you have reached the end or not. So whether your node is null or not, and you are setting node to node arrow next in the next and data. Okay, so the usual browsing thing, and this is also the usual append thing. Okay, append code. Okay, and yeah, so we have discussed the iterator code here. So yeah, so this is another place where you are basically using friend classes. Okay. Okay, so like the question was there that whether, so friendship is neither commutative nor transitive. Okay, so basically if A is friend of B, it does not mean that B is friend of A. And similarly, if A is friend of B and B is friend of C, that also does not mean that A is a friend of C. Okay, and visibility and encapsulation we have declared, we have discussed. So yeah, so basically public is accessible to all. So protected is accessible to subclasses. Okay, only the class and the subclasses. Okay, so you don't know yet what is subclasses, so we'll discuss that. Okay. And then yeah, so I think this pretty much summarizes everything. Okay, so you can have so you can use so the caution here is that you should not use the friend too much, because then what happens is your design becomes poor. So when you do a design, okay, you will see that you will try to do a design. So you will try to define the different classes. Okay, so of a of a complex software. So if you are doing a good design, okay, the number of either member functions or global functions that you declare as friend of some of the classes should be minimal. Okay. Um, okay, but in certain situations you have to do it. Okay, so we will see these situations more. So any question till now? Okay. Okay, so okay, so I mean, maybe if you have questions we can come back. Okay, now let us go to the next topic. Okay, which is basically overloading of operator overloading of using basically member functions. Okay, so so you have already, so yeah, okay, so so you have already seen operator overloading. Okay, so what is the motivation? The motivation is that you want to have something like a user defined type. Okay, so for example, you may want to have a complex type. Okay, so you may want to have a class complex. Okay, and then you may want to overload the plus operator to do complex number addition. Okay, minus operator to do complex number subtraction. Okay, star operator to do a multiplication of complex numbers. Okay, and divide to perform a division of complex numbers. Okay, and then you may want the not operator to do a conjugate of the complex number, maybe. Okay, and then you may want to compare, right? So we using the equal to or not equal to operator. So you may want to overload all these operators. So once you do that, you can basically do a do expressions, or you can write programs using the normal expressions of complex type. Okay, similarly you can do it for fraction type, the same things. Okay, you can do for matrix type. Okay, maybe you can use the exclamation operator for inversion of the matrix. Okay, you can do it for set type, where you use plus for union, minus for difference, star for intersection. Okay, and then subset, superset, etc. Okay, you can do this also. I mean, it is already done, so you do it for you may want to overload the the streaming operators, like read and write operators. Okay, so it, yeah, so it should be the other way around, I think. Okay, so yeah, no, this is fine. So this is the read operator and the write operator. Okay, yeah, and yeah, so these are the things. Okay, then there are some more advanced examples which if you are interested you can look up. Basically, so these include something like smart pointers. Let's say, so smart pointers are basically pointers which 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 you don't have to delete them. Okay, so they are the objects that they are pointing to get automatically deleted when the pointer goes out of the point. So the pointer object gets destroyed. Okay. So something like this. And in this case also, in order to use smart pointers as pointers, you may want to, overload the unary star operator, and then the indirection operator, the copy operator, etc. Okay, and the comparison operator also. Okay. Similarly, you can define objects which look which can be used in place of functions. Okay, so these are called functors. Okay, or function objects. Okay, and you can so you can actually overload the function operator. Okay, so and then use these objects using the same syntax as a function. Okay. Okay. So let us go into let us just do a bit of a recap. I mean, I'm going to go very fast here. So if you have any questions, so this is basically, so you already know operator overloading using the global operator. So this kind of expression a plus b is actually a call to this operator function, operator plus a comma b. Okay, and similarly these expressions. So this we have seen. Okay, where a and b are of some type. Okay. Yeah. So and you can have all these things. So this we have discussed already. Okay. Okay. Yeah. Yeah. So you and okay. So we have now here one thing to note is that these operator functions, okay, these global operator functions, okay, can be a global function. They can also be a friend function. I think we have already discussed this. Okay, so wherein you can so suppose the type is, the object is something which has private data members. Okay, this plus operator can be declared as a friend of this particular type, so that it can so it's a global function. Okay, but it can access the internal data of this particular type. Okay. Okay, and you can also have, yeah, so binary operators, you can have the unary operator as both global and friend. Okay. Of course, friend is better because it is safe, so your data stays protected inside the class. Okay, so encapsulation is only selectively broken for this particular operator. Okay. Yeah, and you can see these kind of things. Okay, now how does the member operator function work? Okay. Okay, so for the same operator plus, okay, so you see here you were defining the operator overloading as operator plus, and it was taking, so it's a binary operator, plus is a binary operator, so it is taking two objects, in this case constant references to objects, okay, of my type, and it is returning one my type. Okay, now here you see what is happening is it is taking only one object, or constant reference to one object. Okay, and it is returning an object. Okay, so what is happening here is that since this is a member function, okay, so the left operand of this this particular object is the invoking object. Okay, so basically you can say that the first pointer or the first object is kind of derived from this pointer of the object for which this is called. Okay, so so that is the semantics here. Okay, and the right operand is taken as parameter. Okay, so this is in case of if you want to have member operator functions, okay, which are which are used. So take this example. So here, if you have an expression like a plus b, okay, this is actually in terms of the member operator, this is actually a dot plus b, okay, which is not same by the way as b dot plus a. Okay, I mean in this case, so it depends on your definition of the plus operator, but the arguments are different. Okay, so this is one thing extra that you need to know about member operator functions. Okay, similarly you can understand so similarly when you have unary operator, okay, in a normal unary operator you would have to pass the object, so a constant reference to the object or a reference to the object, something like that. Okay, here you don't have to pass anything, so the only argument, okay, is taken as basically the invoking object. Okay, so whichever object invokes this is the one. So here you can see plus plus a is basically a dot operator plus plus and then no arguments. Okay, similarly the postscript operator, you remember there was this dummy integer argument which doesn't really mean anything. Okay, it just differentiates the normal operator from the rather the yeah, so the prefix operator from the postfix operator. Okay, 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 so yeah, now again this is a recap slide, so I think you know all of these things already. So these are the operators which can be overloaded, some operators can't be overloaded, and some operators lose some of their behavior when they're overloaded. Okay, so for a member operator function, the invoking object is passed implicitly as the left operand, but the right operand is passed explicitly. So this we have discussed. Okay, and for non-member operator function, global or friend, okay, operators are always passed explicitly. Okay, so this is what it is. Okay, so okay, so now yeah, so you see so suppose you are trying to overload this operator plus, okay, for the complex class. So this left code here is the complex one. Okay, so you can do this, but this is unsafe, right? So this is unsafe because you are using a struct and there is no encapsulation in struct. Okay, and similarly you have seen this also. So these are things you have seen, that you are using the plus operator in case of a string to do a string concatenation. Okay, and again this is unsafe. Okay, so how can you make these safe? So for example, in case of complex, you can do this complex. Okay, and what you can do, you can so here what you are doing is you are providing accessor functions like get and set functions. Okay, and then you are defining this global operator. Okay, which is basically taking two complex objects. Okay, and then it is returning another complex object. Okay, so then if you just call it, if you like say complex c1, c2 and c3, and then you say c3 is equal to c2 plus c1, it shows the correct answer. Okay, now of course you are using accessor functions here. Okay, So that is not an ideal thing, because I mean, it can lead to some overhead, though sometimes the compiler optimizes it, but still it can lead to some overhead, or yeah. So another way to do the same thing will be using this member operator. So in this case, you are overloading the operator plus using a member operator function here. Okay. Again, like we mentioned, it takes only one argument. Okay, and then you add re to c dot re. Okay, and im to c dot im, and then you can do exactly the same thing. Okay. Okay, and here is the thing about operator equal to. Okay, so I think again this you have seen. So this is like basically you are defining a copy assignment operator. Okay, yeah. So yeah, I'm not going through it again. Okay, yeah. Okay, so now. Okay, yeah, so again, this is an example of how you can overload unary operators using using member operator functions. Okay, so in this case, basically my class, and you are so the type is my class and it has a private data. Okay, and you are trying to let's say do the pre-increment and the post-increment operators. Okay, so in the first case, um, what you do is you say plus plus data and then you return star of this. Okay, and you return basically the same object. Okay, in the second case, post increment operator, you take an int, it doesn't matter what. Okay, and then you define a new object of this type. We have discussed this also in case of a global implementation. Okay, and then we do a plus plus data. Okay, for the current object. Okay, but we return t. Okay, so basically the effect is not reflected in the returned object. Okay, of course you can display, and then this will basically work. Okay, okay, so you can just check some code. Okay, any questions till now? Okay. Okay, so let us look at some more cases of this operator increment, this operator member functions. Okay, or some more applications of these operator member functions. Okay, so the yeah, so this we have seen already. Okay, now let us look at this thing about how you want to extend the operator plus to the complex class. Okay, so suppose you remember, so we were declaring this complex d1 and d2, and then we were saying and also d3, and then we were saying d3 is equal to d1 plus d2. So this works, and we have seen how. Okay, okay, now we want to do also like it is logical that we should be able to extend it to the plus operator to complex and the real. Okay, with no imaginary part also, right? Okay, so so we will see how to do this. Okay, so okay, uh, we also want to do, overload these operators, the input and the output operators, in order to basically, you should be able to print complex numbers like this. Okay, so let us look at this example, how, this happens. Okay, so if you were to be using a global function, how will you do it? You will declare the internals as public, or you will use accessor function, something like that. Okay. Okay, and then you would say, so basically what do you want? You want, if two complex numbers are provided, then you should be able to overload this operator plus. Okay, if the first argument is a complex and second argument is a real, which is given by a double, then also it should be able to do it. And if the first argument is a double and the second argument is a complex, then also it should work. Okay, so then you have achieved basically complete, you can think of it as something like an interoperability with the real. So a real number is also a complex number. So just like you are, able to add complex numbers, you should be able to add a real number also to the complex number. And then, this can also basically go on to the other operators. So then you are basically, you are able to operate with the complex number semantics, but you are also able to use double variables, which are complex numbers, but with no imaginary component. So this is the idea. Okay. So, you should be able to do something like this. Okay. Okay. Yeah. So you should be able to do something like D3 is equal to D1 plus D2, or you can just do D3 is equal to D1 plus 6.2, or D3 is equal to 4.2 plus D2. Okay. So this is what we are looking at. Okay. Now this particular solution works. Okay. So the solution that we have provided here works. Only problem is that this is not safe because you are having global variables here. Okay. Okay. So what do you do? Okay. Another solution is using member operator function. Okay. Now member operator function solution we have already seen. Okay. You can have the data, you can have the encapsulation, so you can have the data as private. Okay. But now you see, these two you are able to do. So if the first argument is of type complex, you are able to do using this operator, this overload and this overload. Okay. Okay. But when the first argument is of type, 4.2, then this will not work. Okay. Okay. And here, actually, we have used another thing, okay, which is that yeah. So basically, we have made the constructor here explicit. Okay. So basically, what happens is, so one way this could work is, this particular expression could work is that this 4.2 actually gets converted to a complex. Okay, implicitly. Okay, and then this plus gets called. Okay, so that is one way it could be done. Okay, but if you then you don't have kind of control over this part anymore. Okay, so in this case it may still work. Okay, but for example, it wouldn't work if you had passed the first argument as the imaginary component. Okay, so then in that case it would not work. Okay. So basically your constructor sort of takes imposes the semantics rather than the operator. Okay, so we don't want that, so we declare the constructor as explicit, which means that this kind of a conversion will happen only if there is an explicit cast, otherwise the conversion will not happen. Okay. And in that case, okay, what happens is that you basically, so this will not work now. Okay. So then what do you do, or how do you make it work? Okay, so the better way is to have all these functions as friend functions. Okay, so you have all the three functions which are friend functions here. Okay, and then you so all three will work. Okay, so so in the first function both are complex. In the second function the first argument is complex, the second argument is double, and in this the first argument is double and the second argument is complex. Okay, so
Sir, using friend, like how we are accessing the double value, I'm unable to understand that, sir.
you mean the D?
Like using only the friend keyword, like friend is allowed to means access through different classes.
Yeah, so friend is allowed to access the private and protected members of the class.
Class. Okay, sir. So, sir, this double object is able to like means have this operator plus.
No, you are defining this, right? So here, okay, so first of all, this double is a, yeah, so the second argument here, so you are talking about the third overload, is it?
Yes, sir. Means I am unable to visualize how is double being means accepted in place of object. Like how the method is called, I am unable to understand that.
Okay,
The
so
function is called.
okay. Let me clarify this. Okay, so maybe I was not clear enough. Okay, so see there are three overloads of the operator plus that I have defined. So these are all global overloads. Okay, none of this is member. Clear? Because see, these are all friend functions. So if you remember, if you declare a function as friend, then its name is not qualified by the class name, right? So this is a global function. Okay. Just because it is defined within the scope doesn't mean that it is not a member function. So first of all, get this thing that this operator plus function, none of these are member functions. Okay. So the previous one was a member function. See here there is no friend. Okay. Okay. But this is a
Yes,
friend
sir.
function, not a member function. So this is one thing. Okay. Now, what does that mean? That means that both the arguments have to be supplied. Okay. Only for a member function, only one argument has to be supplied. So the first argument is by default the invoking object, which is this. Okay. So that has to be of type complex. Okay. So that restriction is there. But here, because this is not a member operator function, okay, you can make the first argument as double and the second argument as complex. Does this clarify?
Yes, sir. Yes, sir. It clarified.
Okay. Okay. Yeah. So this is one thing. Okay. Okay. I think we will stop. There is a little bit of one more small example left. So we can like finish the discussion in tomorrow's class, and then we can move on to other things. Yeah. Any questions or comments at this point?